In the previous lecture, we saw that some peripherals deliver their interrupt to the NVIC over the EXTI line, and some peripherals deliver their interrupt directly to the NVIC. And you should remember that this is the design of ST. So you may find some other design in TI. But as I said again and again, at the end, everybody should come and touch the NVIC. Great. So now let's see how the GPIOs are actually delivering their interrupt to the NVIC. So now the answer for that is you have to go and check the external interrupt section in this EXTI section. So here you can see that this diagram, and which explains how exactly the GPIOs are delivering their interrupts to the NVIC. All the 0th pin of GPIO ports are actually connected to EXTI 0 line over this multiplexer. So that means PA0, that means GPIO port A, pin 0. So if we want to match this with our schematic, so let me open the schematic. So let me just open that. So if you want to match this with our STM32 F407 microcontroller, all these pins PA0, PE0 and PB0, PD0, okay, all these pins, they deliver interrupt via the EXTI 0 line through this multiplexer. So that means at any given point in time, you can only touch only one input to the output, isn't it? Because it's a multiplexer. So which one you should select is determined by this register, which we'll explore later. Here you have to configure in your application this register in order to select which among these should come over the EXTI 0 line. Similarly, so all the GPIO ports first pin, this is 0th pin, okay, this is the first, that means this is the second pin. So this is the first pin, this is the second pin, right? So all GPIO ports pin number 1 is connected to EXTI 1 line over this multiplexer, and again you have to configure this register by your application in order to select which input should issue its interrupt over EXTI 1 line. There are up to EXTI 15 line dedicated to issue your GPIO interrupts to the NVIC. Okay, so that covers GPIO pin 0 to GPIO pin 15. As we know, our user button is actually connected to PA0, isn't it? So that means if I press the user button, then my interrupt will come over EXTI 0 line. Okay, so that means I have to implement EXTI 0 handler, right? So that is actually my interrupt handler for the user button.
So in summary, how does a button issue interrupt to the processor in STM32? First one is actually you connect button to one of the GPIO pin of the microcontroller. And remember that that GPIO pin should be configured to input mode to receive the interrupt. Don't worry about the second point, because we have a whole different lecture series to understand different operational mode of the GPIO pin. This you will learn when you go through the driver development section in the course. And the third point is the link between a GPIO port and the relevant EXTI line must be established using the sysconfig register. Again, how to do this you will learn later, but for a time being, just note that there are different EXTI lines, and let's say if you have connected your button at PD0, then you should establish that link. The PD0 should come over EXTI 0 line. That selection you can do by using sysconfig register. By default, sysconfig register links this port A to the EXTI line. that linking can be changed by using the sysconfig register. Suppose if you have connected your button to let's say a PD15, then the interrupt will come over EXTI line 15. But that link must be established by using the relevant sysconfig register. Don't worry, all these things you will learn while coding practically in the driver development exercises. And after that, the fourth point is configure the trigger detection. So at what trigger you want interrupt, whether it is for falling edge, rising edge, or both edges. You have to configure the trigger detection for relevant EXTI line. This is done via EXTI controller registers. For example, if you open the EXTI controller block diagram, you can see that there are various registers, right? Pending register, interrupt mask register, a rising trigger selection register, falling trigger selection register. So all these registers will configure these lines that I'm going to explain in the next lecture. And the fifth point is implement the handler to service the interrupt. This is a summary, or I can say it's an overview, but if you don't understand something here, then don't worry. We have more discussions which are pending related to GPIOs, because in later lectures we are going to understand GPIOs, its port, its various operation modes, and various other things. Just take it as an overview. So I'll see you in the next lecture.